Good morning everybody, I am Sridhar Reddy. Today my topic is rules used to write the electronic configuration. So in order to write the electronic configuration, we have to follow some rules. How many rules you have to follow? Nothing but we have to follow the 3 rules you have to follow. One is called the Paulis Exclusion Principle, Afbau Principle, Hunds Principle. Let us take Paulis Exclusion Principle. What does the Paulis Exclusion Principle says? Paulis Exclusion Principle says that in an atom, any two electron you take will not have the 4 quantum numbers same. So in the earlier classes we discussed, we are having the 4 quantum number, namely principal quantum number, azimuthal quantum number, magnetic quantum number and the spin quantum number. Now what is the Paulis Exclusion Principle says? Any 2 electron in an atom if you take, they will not have the 4 quantum numbers same. They may have the 3 quantum numbers same, but at least they differs in the 1 quantum number. For example, I am taking helium, atomic number is 2, electronic configuration is 1s2, orbital representation if you observe, this is the orbital representation 1s2, nothing but 1 first shell s orbital which has the 2 electron. Now I am taking the first electron, this electron I am taking. I am writing the 4 quantum number n, l, m and n. Principal quantum number, azimuthal quantum number, magnetic quantum number, spin quantum number, particularly for this one n. N is nothing but 1s2, nothing but n is equal to 1. L, s orbital, for the s orbital L is equal to 0. Whenever L is equal to 0, m also equal to the 0. S nothing but spin quantum number, so it is upward direction which is equal to the plus of. I am taking the second electron, I am taking for this second electron. N is equal to again 1, L is equal to s orbital, whenever L is equal to 0, m also 0, S is equal to, it is the downward direction which is equal to minus of, here if you observe. So it is consisting of the 3 quantum numbers same, but they differing in the 1 quantum number. And not only this, any 2 electron in an atom will not have the 4 quantum numbers same, they may have only 3 quantum numbers same, at least they differs in the 1 quantum number which is called the Paulis Exclusion Principle. The second definition of the Paulis Exclusion Principle, if you observe, we can accommodate maximum number of electron in an orbital is 2 with the oppositive spin. The maximum number of electron in any orbital you take, we can accommodate only 2 electron which will have the oppositive spin. One will be the clockwise direction, one will be the anti-clockwise direction. This is about the Paulis Exclusion Principle. Now, Afbau Principle. Second principle is the Afbau Principle. Afbau is a German word which means building up. In building up of an atom, in the construction of the atom, the differentiating electron, the last electron, new electron enters into the lowest orbital energy first. Lowest energy orbital first is called the Afbau Principle. According to the Afbau Principle, in the construction of the atom, the differentiating electron enters into the lowest energy orbital first is called the Afbau Principle. How to calculate the lowest energy orbital? Lowest energy orbital can be calculated by using the n plus L rule. Lowest energy can be calculated by using the n plus L rule. What is the n plus L? Let us take here. I am taking the n plus L rule. I am taking case 1. The orbital which will have the least n plus L value will have the least energy. Come on here. The orbital which will have the least n plus L value will have the least energy. For example, I am taking 2s orbital and 2p orbital which will have the least energy. In order to calculate the least energy, you have to calculate the n plus L value. I am taking the n plus L value for this one and n plus L value for this one. N plus L, n is equal to 2. L is equal to s orbital 0. Ultimately it is equal to 2. For the 2p orbital, n is equal to 2. L is equal to p orbital, L is equal to 1. Ultimately it is equal to 3. Nothing but the orbital which will have the least n plus L value will have the least energy. So 2s orbital will have the least energy than the 2p orbital. That's why electron first enters into the 2s orbital. This is called the Afbau Principle. Case 2. If n plus L is same for the two orbitals, n plus l is same, then how you can say which orbital will have the least energy? The orbital which will have the least principal quantum number will have the least energy. Whenever n plus l is same for the orbital, then we can say on the base of the principal quantum number. The orbital, the principal quantum number is less, ultimately it will have the least energy. For example, I am taking the 3s orbital and the 2p orbital, 3s orbital and the 2p. For this one, n plus l, n is equal to 3, l is equal to 0, ultimately 3. Here, n is equal to 2, l is equal to p orbital 1, ultimately 3. Now look at here. N plus l will be equal to 3 and 3. Then how we can say? We can say on the base of the principal quantum number. If the least principal quantum number will have the least energy, ultimately 3s will have the highest energy than the 2p orbital. 2p orbital will have the least energy. So like this we will calculate. Any orbital, which orbital will have the least energy? How we will calculate? Nothing but we are having one diagram we are having which is called the Euler diagram. Euler diagram also useful in the calculation of the energies present in the different orbitals. Let us take here. I will take the Euler diagram. Let us take it. For 1s, 2s, 2p, 3s, 3p, 3d because third shell will have d, 4s, 4p, 4d, 4f, 5s, 5p, 5d, 5f, 6x, 6p, 6d, 7s, 7p, 8s. Now I am taking diagonally like this. Now you have to write from like this, 1s, 2s like this. So 1s will have the least energy than the 2s. Then you come from this, come on here, like this. So 2s will have least energy than the 2p. 2p will have least energy than the 3s. 3s, 4s like this. You have to write the energies. We can write the different energy can be calculated by using the Euler diagram. Whenever two orbitals it gives you, we can calculate on the base of the n plus l rule. The orbital which will have the least n plus l will have the least energy. If the n plus l's are same, we can say on the base of the principal quantum number. Last and final one, Hunds principle. Hunds principle. Hunds principle is applicable whenever degenerated orbital is available. What is the degenerated orbital? The orbital which will have the same energy. For example, p orbital will have the same energy, px, py, pz, 3 orientation. D orbital will have the 5 orientation. All the 5 orientation will have the same energy, which are called the degenerated orbital. Whenever degenerated orbital is available for the filling of electron, how the electron takes place? First, it must and should get the off-field configuration. Then only the pairing of electron takes place, which is called the Hunds principle. Once again, whenever degenerated orbital is available for the filling of electron, first it must and should get the off-field configuration. Then only pairing of electron takes place, which is called the Hunds principle. According to this rule also we can say any element which will have the off-field configuration or full-field configuration, they will get the extra stability. First they must and should get the off-field configuration, then only pairing of electron takes place. For example, I will take the boron. I will take boron, nothing but 5. Electronic configuration is the 1s2, 2s2, 2p1. Now look at it, orbital configuration, 1s2, 2s2 maximum, 2p nothing but degenerated orbital, only one electron, no doubt it comes like this. I am taking the carbon 6, immediately look at here, 1s2, 2s2, 2p2. 1s2 nothing but only one orbital, 2 electron, 2s2 also 2 electron. Here p orbital will have the 3 orientation, but electrons are 2. So one electron comes here and pairing takes place, or it enters into the next, nothing but enters into the next, because first it must and should get the off-field configuration. That's why like this you will get. Nitrogen 7, ultimately electronic configuration is the 1s2, 2s2, 2p3. So 1s2 nothing but like this, 2s2 nothing but like this, 2p3. Now you are having the 3 orbitals, px, py, pz, 1 electron. That's why now you will get the off-field configuration. Then only pairing can be takes place, which is called the Hunds principle. This is the important rules we have to follow in order to write the electronic configuration. One is called the Paulis exclusion principle. No 2 electron in an atom will have the 4 quantum numbers same. and the next one will be the Afbau. The electron enters into the lowest energy orbital first. Hunds principle, whenever degenerated orbital is available for the filling of electron, first it must and should get the off-field configuration, then only pairing of electron takes place. Thank you.